Hi guys, I hope you're doing well. So this is the video for the second part of the answer key. So good for you. If you're working on this, that's awesome. Remember, these are kind of the hard questions because they're really wordy and, it's cumulative. It's like trying to remember everything. So be proud of yourself and don't try not to get discouraged. So also I put the Blackboard portion of this on Blackboard. So, after you practice this, go ahead to Blackboard and to course materials. Click on the go to assessments, and this would be the March review test, and see how you do. There's no password, and you can take it as many times as you want. After each time, it will tell you which ones you got wrong, and it'll tell you the answer, so you can kind of learn from your mistakes. I will give you credit for doing these things. As always, you get credit for everything you do. So feel free to email me, keep me so I can make sure I update your grade. I don't think really you guys have to worry too much about your grades. It's a matter of trying to get them, as high as you can. All right, because you have the rest of third quarter and all of fourth quarter to raise your grades. So take advantage of this. And there's also a lot you can learn by, practicing the kind of learning online. You're really learning a lot more than just chemistry. I know I am. Okay. So here we go. Where did we leave off? I think I was in the middle of talking about this question about the experimental design. What was it trying to study? And we said, okay, you've got the dependent variable is right here, which is the rate, right? And which all of these are talking about how it's affecting the rate. All right, so the question is it the temperature, the surface area, a catalyst, which is something that speeds it up, or an acid? All right, so what we're talking about here, if we go and look at it, well, we've got crushed marble chips and we have whole marble chips. So that's our IV. What did we change? We changed the kind of marble chips we've got, the size of the marble chips. All right, we didn't change the temperature. We didn't introduce a catalyst. There's nothing about a catalyst here. There's nothing about an acid here. But we are talking about the size of the chips, and that has to do with surface area. All right. So the whole ones are going to have a less surface area than if it's crushed. All right. So that is why that's the best answer. That's the best fit. The next one, it says, which of these elements is most chemically active? Remember, on your periodic table, the chemically active ones are in that upper right-hand corner, all right? And so fluorine is the most chemically active. It's got the highest ionization energy and the highest electronegativity. Which of the following equations is balanced? And we hadn't talked about this before we went to break, but there is the notes for this are online, and you can print them out and write them out. There's practice problems in there. There's a whole section. If you look at our Google site, there's activities to help you learn how to balance equations. And then, of course, when we get together, I'll make some more answer keys and you can practice on your own. And when we get together, we'll talk about it and practice as well. It's not too hard of an idea. You're just balancing the numbers on both sides. So I'll go ahead and explain this one. What you do is if you've got two elements, right? You've got sodium. So we're kind of introducing this, and it's not really a review, but I think you'll be able to understand it. Sodium and calcium are the two elements, right? Oops, I didn't want to write it like that. Where's my eraser? All right, I have two sides of my equation, right? The left side, my reactants, and then I have my, products. I ordered a pad, so I'll be able to write much better when that comes. I can't wait till that comes. So we have sodium on both sides and we have chlorine on both sides. So let's change the color here. We've got, and then we just count. Well, and see which one has them equal. Well, this one has 1 sodium and 2 sodiums here. So that can't be the answer. That's not balanced, right? The whole thing is balanced, which means it's equal on both sides, right? So this has 1 sodium here, and this has 2 sodiums, right? Remember the number in front, the coefficient, that's the number of moles. So this has 2 moles. So 1 does not equal 2. So it's not G. How easy is this, right? If you look at J, J has 2 moles of sodium here and 1 mole. Remember, if there's no number in front, and then this would be your subscript. This 2 doesn't go with the sodium at all. So you have 2 atoms of sodium here and 1 here. So it can't be J, it's got to be H. So let's just confirm. We have 2 here, right? 2 sodium and 2 on the left and 2 on the right. Here, remember I have my subscript, so that means I have 2 chlorines, and over here, this 2 gets distributed over here, so that means I have not just 2 sodiums, but I have 2 chlorines. So 2 and 2. All right, and that would be balanced. So that's why J is balanced, or H is the answer. So that's easy enough. The correct formula of an ionic compound, I put this here for the crisscross. Remember, you could say, okay, the 3 goes down over here. So that's why we have the 3 here, right? The charge of aluminum was +3, so you'd cross it over and the 3 goes here. And then if you take the charge of the carbonate was -2, so that crosses off over to here. So that's where you get this 2 here. All right, so there's the 2 that came from this 2, and here's the 3 that came from this 3, crossed over. All right, or remember how we figure that out, they have to add up to 0. So I have A3, or excuse me, aluminum, which is +3, and I have carbonate, which is -2, right? Remember that was a polyatomic ion that we had to memorize, and they have to add up to be 0. So I'm going to find the least common multiple. Remember 3, 6, so it'd be 6. So that means I need 2 aluminums, right? 3 plus 3 is 6. So this would be a +6 if I have 2 aluminums. So there we go. And then this is -2, so I need to have 3 of them, right? CO3, that would be -2. And then CO3, carbonate, -2. Each one of them is -2, so that's -2, 4, 6. So I've got -6 and +6, that adds up to 0, and that's why this is the formula. This is saying I have 3 carbonates, 1, 2, 3, and I have 2 aluminums, 1, 2. Okay, now the next one, you've got a chemist looking at an unidentified example, a sample of an element. The oxidation states vary. You can have +2, +3, +6. So it's a cation, it's a metal, right? And what are the metals that have different different oxidation states, different what are the metals that can be +2 or +3 or +6? Those are our transition metals, okay? And then it's in the same period, potassium, the same period as potassium. So that's what it has to do with potassium. All right, remember the periods go across and the groups go down. So it's the same period as potassium. So you have like potassium here, and then this would be a transition metal right in here. Okay, so now we've got methyl mercury found in some stream sediments is highly toxic to animal life. Using the graphed results of the study shown, the best analysis of the data reveals that the methyl mercury concentration is, and this would be, it's definitely decreasing, right? Goes from almost 4 down to 1.5. It's definitely decreasing. So this fits. Constantly decline, but constantly declining, no, because it's going up and down, right? So it's not constantly, all right? And that's why that is out. This says increasing, right? So that's why that's out. And this says increasing. So that's why that is out. So it's decreasing, but it reaches a maximum rate at the end of summer. So the end of summer is like August, right? So here's the maximum in the summer. And yes, that fits. All right, so F is your best answer. Big part of chemistry in all inner science classes next year will be just being able to read a graph. You don't have to understand what it's saying, but understand what the graph is telling you, you know, about maximums and decreasing and increasing. An experimental experiment produced 0.10 grams of carbon dioxide with a volume of this many liters at standard temperature pressure. The accepted density of carbon dioxide is this. What is the approximate percent error? So remember, percent error is, well, error is like how much off you were, right? So how much off you were is you're going to subtract to find the difference. So I'm going to take the accepted value is 1.96. And I'm going to find the difference. So I'm going to subtract what I actually got. So I was expecting to get this, I got that. So how far off was I? All right. If I subtract that, that would be 1.86. Right? And then now I have to divide by, now that's the actual error. Now the thing is, that could be a big error, it might be a little error. It depends on if you're expecting to get 1 or a million. If I'm expecting to get 1, that's a small error. If I'm expecting to get a million, that's way off. So you have to compare it to what you were expecting. What was I expecting? The 1.96. So I'm going to compare, and we do that in math by dividing. All right, and that will give me a decimal, right? So I'm going to do that on my, I've got my phone here. I forgot to put up Desmos. So let's see, we've got 1.86, and you should be doing this too. Or have done this so that you know what to do. You'll be able to do it on your own. So that gives you 0.9489. But I want that as a percent, right? It says percent error. So remember what we always do is we times by 100, which just moves the decimal over 2 times. And so that would be... I'm going to times by 100 or move my decimal over 2 times, so I get 94.9. So was that a big error? Yes, it was. I was way off, right? So I should probably redo that. All right, so this one, it says again, we're talking about the coefficients, which would be the numbers in front here, right? If I put numbers in front, those are coefficients. All right, but I can't just put random things, they've got to be balanced. All right, so let's go ahead and do this one just for so I just write and make a list of my elements, right? So I've got hydrogen and I've got oxygen. And I have reactants on the left and products on the right. And I want both of them to be the same. All right, so let's see. I've got, so far, if I look at the hydrogens, right, there's 2 hydrogens and 2 hydrogens. So 2 hydrogens and 2 hydrogens. That looks good so far. If I don't do anything, if it's just 1, 1, 1. But now this means, remember, this subscript would be a 1. So I only have 1 oxygen here. And over here, because oxygen is diatomic, right? Remember that diatomic? Diatomic means you have 2 atoms always together, right? Di means 2. So those highly reactive elements over on the right-hand side of the periodic table, remember there's 7 of them, including hydrogen, which is not over there, but hydrogen, and then starting with nitrogen and then making a 7 here. Those are diatomic elements because they're always found in pairs. They're highly reactive, so it's always H2N2O2 and so on. F2. Okay. So 1, 2. So I have 2 here. Right, now the rule is you can't just put a little 2 here because that would change, it wouldn't be water anymore, right? This is water. If I put 2 here, it's hydrogen peroxide. So I can only add coefficients, right? You can only add a number in front. So I'll put a 2 in front, right? And then now, though, so now I have 2 oxygens, right? And 2 oxygens. So that works out good. But I have 2 times 2, I have 4 hydrogens, right? Because this was H2O. And if I put a 2 in front, that means I have 2 H2Os, 2 moles of water. So that would be 2 plus 2. Now I have 4 hydrogens on the left. So to get 4 hydrogens on the right, I'll just do the same thing. I'll put a 2 in front. And now I have 2 times 2. I have 4 hydrogens in front, or on the right-hand side. All right, now the last thing you always do is check your answers. All right, so what I'm saying, so I'm saying this would be a 1, right? I have 1 mole of oxygen because I didn't put anything there. All right, so 2, 2, 1. So let's just check and make sure that that is definitely balanced. So I've got 2 times 2 is 4, check. 2 times 2 is 4, check. Here I have 2 times 1 is 2. And then here I have 1 times 2 is 2. All right, so that would be balanced. So the coefficients are listed here. It would be 2, 2, 1. Right? 2, 2, and 1. So 2, 2, 1. So this is the best answer. All right, here we have standard atmospheric pressure. It's 101.3 kilopascals. All right. According to the graph, which of these 4 liquids boils And where does the boiling point is oh, actually, okay, it boils at the lowest temperature. So 100 is boiling, right? 0 is freezing. Boiling would be oh, sorry, I've got I'm sorry. That's like at normal pressure, we have like water boils at 100. But here we're saying that which is boiling at the lowest temperature. All right. So here's my temperature. So the lowest, the one that hits this line at the lowest temperature would be 1 right there. And that's why that is your best answer. Sulfur is represented by the following Lewis dot structure. Remember, you have the element in the middle. And it has 1, 2, 3, 4, 5, 6 valence electrons, right? 6 valence electrons. So which one of these would also have 6 valence electrons? That means it's in the same group, right? So let's check out our, I forgot to open up this beforehand. Sorry about that. So here's sulfur, right, with 6 valence electrons. So which of these groups is in the same, or which of these elements is in the same group? It would be oxygen, right? Here's sulfur, here's oxygen. So they both have 6 valence electrons, right? 1, 2, 3, 4, 5, 6. If we look at magnesium, it only has 2 because it's in group 2. And phosphorus has 5, right? Same as nitrogen. And chlorine is over here. Chlorine has 7 valence electrons, just like fluorine and bromine. And these are your diatomic, here's that 7 I was talking about earlier. All right, these are your diatomic elements. So there's 7 of them, 1, 2, 3, 4, 5, 6, and then hydrogen is also diatomic. All right. And that's it. All right, so go ahead and look this over. You can use this to help you and open up that, go to Blackboard, kind of try to get back in the groove, course materials, the assessment for the March review. Hope you're all doing well. Stay safe. Bye.